Car safety features are getting more sophisticated and technologically advanced every day. These are the top safety features that have had the biggest impact. Lights on automobiles have always been critical to driving safely. Brake lights, turn signals, and headlights should be checked frequently to make sure they are operational at all times. And in case you didn't notice, turn signals only work if you use them. Another type of lighting used today are daytime running lights, which significantly increase the visibility of a vehicle in daylight and are a low-cost device that helps reduce daytime crashes. Seatbelts. Seatbelts became mandatory standard equipment in vehicles starting in 1966 by federal regulation. It wasn't until about 1984 that the first state law requiring motorists to use seatbelts was put into effect by the state of New York. Seatbelts are proven to save lives and reduce injury, so be sure to always buckle up. Airbags. In 1998, airbags became mandatory standard equipment on both sides of the front seat. Airbags have dramatically evolved since then to include front and side impact airbags, as well as sensors to determine exactly what level of power at which to inflate. Airbags save lives. You are 30% less likely to die in a front-end collision because of airbags. Anti-lock brakes. During an emergency braking situation, in the very early days of automobiles, cars would swerve and skid to a stop. In the 1920s, the swerving problem was eliminated with the addition of four-wheel brakes. Today, you can stop in a hurry on dry or wet surfaces with little or no skidding. Anti-lock braking systems allow drivers to safely maintain control of their vehicles.
The pedestrian underhood airbag. Just when you thought they'd put an airbag everywhere inside the car, Sweden's Autoliv puts one outside the car. Because statistics show that a lot of pedestrian injuries and deaths happen when you're hit by a car and your head wings down and finds that rigid area at the base of the windshield. This puts an airbag right there to cushion you. Pedestrian impact sensor. Now, to detect that pedestrian impact, a rubber tube is laid along the inside of that flexible front bumper. During an impact with a pedestrian, the tube is collapsed a little and that generates a puff of air, which is read by a couple of simple sensors on each end of the bumper. And in 1/100th of a second, they can figure out if it's a pedestrian versus a parking lot sign and fire the airbags. Camera and sensor module. It used to be that the ultrasonic sensors in your bumper, those things that beep, and the camera in the back of the body, which shows you what's back there, operated completely without any knowledge of each other. That left the driver having to blend all that info. But France's Valeo has merged them into a single module, so it all works together, and it's a tiny component that has the added benefit of leaving your bumper without those little sonar dimples in it. Center front airbag. Okay, just when you thought they really had put an airbag everywhere, including under the hood, Takata worked with GM to slide one in between the front seats. This helps to secure the driver during a far side of the car T-bone impact, or to keep the two front passengers from smashing heads and hurting each other. But with this and up to 8 more airbags in the front of the car alone, green airbag inflator. Now, when all these airbags go off, they are typically powered by what's called a sodium azide inflator. It's basically a little rocket propellant in your face, and it's received some nasty headlines lately. The Swedes, being the greenies they are, took note, and Autoliv developed a bag inflator that uses mostly hydrogen and oxygen and leaves behind mostly water vapor. If you could get these in a Nissan Leaf that is charged off a windmill, that's pretty green.
Adaptive cruise control, like regular cruise control, allows the driver to set a desired travel speed. The difference with these systems is that forward-mounted sensors are used to maintain a safe gap based on distance and speed to the lead vehicle. If the lead vehicle begins to slow, adaptive cruise control uses the engine and brakes to slow the vehicle and maintain the preset gap. Some systems allow the driver to specify longer or shorter following distances. When the lead vehicle begins to speed up, adaptive cruise control automatically accelerates the vehicle up to the set speed. If the vehicle slows below a certain speed, some systems may disengage and warn the driver to brake, while others may bring the vehicle to a complete stop. Lane departure warning systems track a vehicle's position within a lane, usually with a camera mounted on or near the rearview mirror. If the system determines a vehicle has or will inadvertently stray out of the lane, it alerts the driver. Most systems consider the movement unintentional if the driver doesn't use the turn signal. Alerts vary and may include a sound, a vibrating seat or steering wheel, and a visual warning. Lane departure prevention systems help direct a vehicle back into the lane through light steering or braking.
Forward collision warning system. The system monitors the distance between a moving vehicle and a vehicle in front of it and warns the driver of an impending crash. FCW, or forward collision warning, uses sensors and computer technology to detect slower moving or stationary vehicles. The equipment monitors a vehicle's speed, the speed of the vehicle in front of it, and the distance between the vehicle and the vehicle in front of it. When the distance becomes so short that a crash is imminent, a signal alerts the driver so the driver can apply the brakes to prevent a potential crash. Vehicles with this technology provide drivers with an audible alert, a visual display, or other warning signals.
Imagine a future where vehicles are able to communicate with each other. This vehicle-to-vehicle, or V2V, technology would provide drivers with crucial information when they need it and provide them with a warning of a potential crash. V2V provides drivers with 360-degree awareness of similarly equipped vehicles within a range of approximately 300 meters, or 984 feet. This secure system keeps personal information anonymous and does not track your vehicle. Drivers will receive warnings that inform them of potential hazards through a visual display, seat vibration, or tone. These are only warnings. The driver remains in control of the vehicle at all times. These warnings can help drivers respond quickly to avoid potential crashes. For example, the Intersection Movement Assist application warns drivers when it's unsafe to enter an intersection. The Do Not Pass application warns drivers when it is not safe to pass a slower moving vehicle. The Emergency Electronic Brake Light application notifies the driver when an out-of-sight vehicle several cars ahead is braking. The Blind Spot Warning application allows drivers to virtually see what's happening in his or her blind spot. These are just a few of the apps that may be available to help prevent car crashes in the near future.
Since 2008, every Honda has been equipped with a tire pressure monitoring system, also referred to as TPMS. The TPMS is designed to alert the driver of significantly low pressure in one or more of the tires. Many TPMS systems in Honda vehicles use sensors inside the wheels to determine if the tires are inflated to proper specification. Proper care and maintenance of the tire pressure monitoring system is necessary to help ensure that the system will alert you in the event of a significant pressure loss in one or more tires.
The active blind spot detection warns of critical situations when changing lanes and thereby actively increases the safety, for example, on the freeway. Checking the surrounding area of the vehicle on the side and in the rear is especially important when changing lanes. However, depending on the situation, certain areas next to and behind the vehicle are not easy to see. Therefore, when the system is activated, the sensors in the rear bumper monitor an area behind and next to the vehicle.
If the driver tries to push the vehicle beyond its limits, the integrated rollover protection system will engage to actively counteract the risk of rolling over, and this is a standard feature. A gyro sensor monitors how much and how fast the vehicle inclines. When a risk of rolling over is determined, The roll stability control system is activated to stabilize the car by braking one or several wheels selectively, and if needed, reducing the engine torque.
Night vision assistant continues to enthrall me. As a driver, you see pedestrians at the side of the road relatively late at night, especially on badly lit, dark country roads. Pedestrians are detected much earlier with the thermal imaging camera used by the night vision assistant. The image of the detected pedestrian or large wild animal is shown on the instrument cluster display and highlighted in yellow.